Guys, we're going to talk today about enzymes and the different types of enzymes and where they're found. So the first type of enzymes we have are the enzymes that break down protein, and these are called the proteases. And proteases break proteins down into their small parts. And I want you to remember that a protein is a long chain of amino acids. Amino acid, amino acid, amino acid, amino acid. And what proteases do is they attack the joins between the amino acids to create the individual amino acids free from each other, which can then be absorbed into the blood because they are so small and therefore they are soluble. So a large, big protein mass, like say a steak, could never dissolve in your blood, but if you break them down to the small amino acids, the individual amino acids, they can dissolve in your blood, and proteases are breaking them down. We need to know examples of proteases. Now, they're found in two places, and the two places that they are found is one in the stomach, and this one has a specific name, and it's called pepsin, and it needs acidic conditions. And that's why HCl is added to the stomach. The second place that proteases are found is the small intestine. And these are general proteases. And they need alkaline conditions. So bile produced by the liver is added to the small intestine. And each of those enzymes will act better in those conditions. Pepsin in the acidic conditions of the stomach, and other general proteases in the small intestine in alkaline conditions. So bile is added to neutralize the acid that's being squirted into the small intestine from the stomach. Now, in terms of why a protease needs, and any enzyme needs, a certain type of acidity, we call it pH, it's that, imagine you had an enzyme and it is a very certain shape. This needs a certain shaped substrate. And this is the active site. Now, what you need to know is that if you change the pH, the acidity of an area that the enzyme is in, you're going to ever so slightly change the shape. Imagine this green line disappearing and that whole cleft suddenly being now that shape where the red pen is. That now is too big a space for that to fit beautifully. And because enzymes and substrates have to fit perfectly, that no longer fits that. And so this enzyme wouldn't work if you changed its shape. And what you need to know is that different pHs can change the shape of enzymes. So pepsin in alkaline conditions would have its shape changed, and that wouldn't work for breaking down proteins. It wouldn't get in here in this very specific shaped parts of between the amino acids. So it wouldn't work. Likewise, taking a general protease and putting it in acidic conditions would change its shape, and it wouldn't work. And this is the same for any enzyme. It needs to be in its right pH conditions. For proteases, pepsin in the stomach needs acidic conditions, and other proteases in the small intestine need alkaline conditions. So that is proteases. Now, we're going to move on to lipases. So, lipases break down fats. But in order to work out what lipases break down fats into, we need to remember what a fat looks like. And a fat looks like this. It's got a long, thin glycerol molecule with 3 fatty acid tails. And when lipases work, they break down the fats. And remember, fats can also be called lipids. They break down the fats or lipids into glycerol and the fatty acids. These are small parts now that are soluble because they're so small, so they can be absorbed into the blood.